Good morning, or good afternoon, or good evening, depending on where you are in the world. Welcome to today's webinar, Rix, Reproducible Data Science Environments with Nix, brought to you by the R Consortium. The R Consortium supports key organizations developing R infrastructure through grants and sponsorships worldwide. Please visit our website to learn all the details and how your organization can become a member. I'm Jesse Kasman, today's moderator. I have just a few items before we begin. In fact, I'd like to give a little bit of information about R Medicine 2025, which is coming up in June, 3 months from now. And Dr. Emily Zabor from the Cleveland Clinic is here just to give a little bit of information, and I'll let you know what's coming up with R Medicine 2025. Emily, please.
Great. Thank you so much, Jesse. Just going to share a few slides to quickly give you a little overview of what's to come in June with the R Medicine Conference. It will be happening Tuesday, June 10th through Friday, June 13th. And we have 2 days of workshops and demos, the first 2 days of the conference, followed by 2 days of lightning talks and regular length talks. And the program is open for submissions now, but we do have some great keynote speakers lined up, focusing on AI topics. Zayed Obermeyer speaking on reinventing medicine with AI, and Aaron Liddell speaking on model evaluation from machine learning to generative AI. And we already have a great list of workshops and demos that are on the program, and we'll be accepting more abstracts for these as well. So go to the website to take a look at the program, and you can find the link to register, a link to submit to join the program, and also a link to enter the data challenge there. So hope to see everyone there.
It's fantastic. Thank you, Emily. Okay, for today's webinar, you can ask questions at any time. Find the Q&A icon down at the bottom. It's the box with the question mark. Type in your question and click submit. And near the end of the webinar, our speaker will try to answer as many of the questions as we have time for. About that speaker, Bruno Rodrigues is the head of the Stats and Data Strategy departments in the Ministry of Research and Higher Education in Luxembourg. He's an experienced data scientist with demonstrated programming, advising, and teaching skills. He uses machine learning and econometrics to solve complex problems. He holds a PhD in applied economics from the University of Strasbourg. Okay, Bruno, thank you very much. Please take it away.
Thank you. Thank you very much. Thank you very much for inviting me, giving me the opportunity to talk about reproducibility. It's a subject I like very much, and I've been working on it for quite some time. And today I'm very happy to talk about a package I worked on called Rix. So I will be sharing my screen, and we'll be looking at some slides. I have some slides just to give a little bit of context, but then I will have also a live demo of Rix, and I'll show you how it works on a couple examples. So as you said, Jesse, I'm the head of the statistical department at the Ministry of Research and Higher Education in Luxembourg. So I have just one slide to explain what Luxembourg is. It's this tiny country sandwiched between France, Germany, and Belgium. We are a very small country, 2,500 square kilometers, or about the size of Rhode Island. We have a bit more than 500,000 residents, so we're very small in size and in population compared to many other countries or US states. So today it actually snowed here, so yeah, pretty bad weather as well. That being said, you are not here for a talk about Luxembourg, but for a talk about reproducibility. So these slides and all the code that I'm showing are available on my GitHub. So there's these 2 links there. Just you can visit them. You can download the code, fork the repository, whatever. And of course, if you have questions, as Jesse said, you can ask them, and I'll do my best to answer them. So the things I want to talk to you about today is I want first to identify with you what should be managed for having a reproducible project. and then give a short intro to Rix and Nix. So they're two different things. There's Nix and Rix, and I'll explain, what Rix, how Rix uses Nix under the hood to do what it does. Also, let me clarify what I mean by reproducibility. I think that's important. I'm really talking about the ability to recover exactly the same results from an analysis. So it's not just, rerunning the same code on maybe updated data, or rerunning a similar study, maybe with a new software stack. No, it's really exactly running exactly the same code, exactly the same data, and recovering exactly the same results. And so really reproducing one-to-one an analysis, maybe 6 months or 6 years in the future. And to turn an analysis reproducible, I like to think about these 4 questions. So how easy would it be for someone else to rerun the analysis? How easy would it be to update the project? So updates, it could mean maybe there's a new data, and a data update, or maybe there's a package update. And then, of course, you want the result might change, but then you want this change in result to just be impacted by this updated data and by nothing else. How easy would it be to reuse the code for another project? And what guarantee do we have today that the output is stable through time, so that if I rerun this code, this analysis, I will get the same result? Do we have any type of guarantee that this is the case? So if you can provide a satisfactory answer to these 4 questions, or to at least 3 of them, depending on your use cases, then you could argue, you could make the case that your project is reproducible. But there are some gradients. Okay, it's not always very easy. It's not always black and white. There are some gradients to it, and that is also the subject of not quite the next slide, but almost. So so reproducibility is on a continuum. So there are 4 things that might influence your results. The version of R itself, even though R is quite stable, but there have been some breaking changes in its history, or changes that had an impact on results, but it's very rare. However, versions of packages, that is much more common. The operating system itself might impact the results as well. So you can rerun the same code on the same software stack, but on different operating systems, ended up with a different result. It's very rare as well, but it can happen. And then finally, the hardware can also have an impact. That is also quite rare, especially for our purposes, but in other fields, like high frequency trading or things like that, it could be more common, or in physics, I guess it could be more common. So as I said, it's not black and white. Is your project reproducible? Is it not? Or it's more on some kind of continuum, on some kind of gradient. So I like to show this image from a paper by Roger Peng from 2011, that explains that if you just have your publication, a paper, right, that is not reproducible at all. That's the point the authors are making. But if you add the code of the analysis, if you add code and data, if you add what they call the linked and executable code and data, so I guess for our purposes we could talk about the computational environment, the development environment, right? If you add that on top, then you reach this gold standard of reproducibility. And that's really where we want to go. And it turns out that Nix is a tool that really makes that, I would say, maybe not easy, but at least possible, because reaching the gold standard is not easy. So I also want to make this very clear. This is not an easy topic. And the more you try to reach this gold standard, the more difficult it gets. But we have tools now to make that possible. So let me also just go through some packages that exist right now that are very popular for reproducibility. So in R, you have renv, which I would say a lot of people are very likely familiar with, or at least you have heard of it. This is a package that is very easy to use. You just open it in your R session, in the folder that contains all your analysis scripts, and then you run renv init, and you end up with a file called renv.log. And this file, if you open it in a text editor, you'll see it's a list of packages with their versions and the repositories they were downloaded from. Okay, and you can use this file on another machine to restore exactly these packages. So this is very useful because you can share that among co-workers. If you are working on a project, collaborating on a project, you can share that, and everyone can have the same packages on every machine. And you can also use it, for example, on a CI/CD platform like GitHub Actions to set up your environment over there. That being said, the issue with renv is that it only records but does not restore the version of R itself. It just does that for packages. So you still have to manage R in another way. So you have to install the right version of R, or maybe install a version and hope that it's compatible. Again, usually it would be the case, but again, it's a risk that you need to manage. And installing old packages can fail due to missing operating system level dependencies. So the older your renv log file, the likely it is that you won't be able to restore it, okay? Because your operating system keeps evolving, and at some point you will just be missing some required libraries for it to work. Again, I mean, it depends a little bit on if you have many packages in these log files or not. But in my experience, that is usually the case when I have this, sometimes 2 or 3 year old log files. I just can't restore them anymore, and it takes quite some effort to do that. But it's possible if you combine renv with Docker. So this is another very popular tool that you might have heard of. And Docker, you will combine Docker and renv to essentially capture not only packages with renv, but also capture the R version and capture these system level libraries, right? So Docker is a containerization tool. You install that on your computer. It's available for Mac, Windows, Linux. And it allows you to build so-called images. And from these images, so they're definitions of environments, from these images that are definitions of environments, you can run containers, okay? So a container is an instance of an image. And these Docker images, what they provide are all the software and code needed to run your project. They are immutable, so you cannot change them at runtime. Well, I mean, you can change them at runtime, but it's not persistent. So if you close your image, if you stop your container, and if you rerun it, then you lost the changes. So if you want to change it, you need to rebuild the image with your changes and then run containers anew. And these images, you can store them and you can share them online and offline. So this is great because you can solve the issue from before where you can, if you combine Docker and renv, you have all three basically. You have R packages, you have R itself, and you have system level dependencies, because these images, they are actually almost complete Linux operating systems. So they are operating systems that run right on top of your laptop, on top of your server, whatever. And so they contain all these system level dependencies inside of this box, if you want. So if you are familiar as well with the concept of virtualization, it's quite close in, conceptually, I would say. Now, is Docker a panacea? I don't know how to pronounce this in English. A panacea? I don't know. But in any case, I think you know that word. So Docker is very useful and very widely used. So even though I am a very big Nix fan, as you will see, I'm not saying that you should throw Docker into the trash. On the contrary, actually, I believe that probably you need to combine both Nix and Docker, but I'll say more on that later on, because it's a bit early to explain this yet. But so Docker, definitely very useful, widely used. The entry cost is high though, because as I explained, these are basically Linux operating systems that you need to know how to use. So familiarity with Linux is recommended. It's also, and this is a bit of a stretch, I must admit myself, but it's also in a sense a single point of failure. So what happens if Docker gets bought, abandoned, or whatever? This is, however, quite unlikely because Docker is popular and there are alternatives. So Docker is built on top of a standard, and there are other tools to manage these images and to run containers. An alternative, for example, is Podman. So you could use Podman instead of Docker. And so, yeah, this is a bit of a stretch, but still, it's a single point of failure. You have to think about it a little bit, or what happens if your company decides to not use containers anymore, right? So this can also be an issue. So it's good to have an overview of what is out there. And also, Docker actually in itself is not really dealing with reproducibility per se. We are, in a sense, abusing Docker. So what we're doing is that we're building this image that contains what we need, and then we store it and hope that we don't lose it. But if we do lose it, and if we do need to rebuild it, then this build process is not reproducible in itself. If you want to make it reproducible, you have to actually work to make it reproducible. You can make it reproducible, but it's not something that comes for free, okay? But it's possible. And by the way, please check out the Rocker project. So the Rocker project is a project that builds and offers these pre-built Docker images for R that contain, they contain Shiny, they contain a lot of different tools installed. So you don't need, if you are not familiar with Linux or whatever, you can use these Rocker images to get started very quickly. So highly recommend that you check out the project. Okay, so now Nix. Nix brings us to Nix, and I'm just checking the time. Yeah, I have enough time. That's good. So Nix actually is a package manager, okay? And so it's a tool that you install on your computer to install other packages. And here I mean package in the very wide sense. It's not just R packages. It can be any piece of software. You can use Nix to install Firefox if you want. You can use Nix to install R itself, to install R packages, to install Python. Actually, the repository of Nix is the biggest repository of any open source project available. It has more than 120,000 pieces of software. So it's the most comprehensive and also the freshest. Almost any package will be updated there very quickly. Of course, there are exceptions, but if you compare to other open source projects, Nix is the one that is, the most comprehensive and the most up to date. If you are not familiar with package managers, let me show you a very popular one, which is this thing, which is the App Store on your phone. So the App Store on your phone, whether you are using an Android phone or an iPhone, is actually also a package manager. It's just a tool that allows you to install other pieces of software. So it's the same thing. If you are using a Mac, maybe you are familiar with Homebrew. Homebrew is also a package manager. And if you are also familiar with Linux, Ubuntu, for example, then you should also be familiar with the concept of package managers. It's mostly Windows that, they have a store now, but it's not that popular. I have the feeling people still kind of download the pieces of software individually and install them. I have a feeling that's still the most popular way to do it on Windows. Anyway, Nix is on, there's a typo there in reproducibility, but Nix really makes it possible to reach this gold standard of reproducibility, which is managing R packages and other dependencies. And it does that because actually Nix was developed 22 years ago. I think it turned 22 yesterday. Actually, I saw a tweet. It turned 22 yesterday. And actually it was built or made with reproducibility in mind. So it's really the primary design goal of Nix is to have a package manager with reproducibility in mind. This means that when you install a piece of software, right, with Nix, that piece of software will be built and installed and deployed in a way that will be always absolutely exactly the same anywhere. So if you are able to build it on your laptop today, you'll be able to rebuild it tomorrow and 5 years down the line as well. Okay, because Nix is just built that way. It's just made to create these reproducible builds. So Nix deals with everything, deals with R packages, system level libraries, etc., by writing a single text file, okay, a so-called Nix expression. And these Nix expressions are written in the Nix programming language. And it's not a very complicated programming language, but it's still a new programming language nonetheless. And asking people to learn a programming language to install software is a bit much, I must say. So that's why I wrote Rix, because Rix will write these expressions for you. And as I said, these Nix expressions always evaluate and build the exact same output. So so Rix is this R package that I've been working on for quite some time now, together with Philipp Baumann, and we got contributions from other people as well, that makes writing these Nix expressions easy. it provides this very simple Rix function. You provide a date or an R version, but I really prefer working with dates, actually, I must say. So I use dates a lot. You put a date there, you put the R packages you need. If you need system level packages, so for example, the system level packages could be like if you need Git, for example, or if you need some other tool, whatever, you can put it there. If you have R packages that are hosted on GitHub, you can put them here. If you want to add LaTeX packages to typeset your paper, you can put them here. Here you can put a development interface. You can put RStudio, you can put code, Codium, Positron. That's all available. So you put it there, and then you evaluate this, you run this function, and you get a so-called default.nix file that appears in your projects directory. And this default.nix file is it's this Nix expression that was written for you. And then you can build that expression, and you can then use the environment to work with your to do your analysis, basically. So you can also use renv log files as a starting point. So actually, this was a very good, very cool contribution by a contributor, not by me nor by Philip. So this is really one of the greatest things about open source is I started this thing, and now I have talented people that know programming much better than me that just contribute to it. So this is really amazing, and they built this great renv to Nix function. So it takes this renv log file as an input. You can also optionally override the R function, like if you want to update, this the R version there, and it just generates the expression from the renv.nix from the renv.log file. Amazing function. And so this lists the required R version and packages, and as I said, optionally you can add packages hosted on GitHub, on GitLab as well, if I remember correctly. That works as well, but not other sites like that. LaTeX packages, and as I said, optionally you can put an IDE there. There's also Radian. This is this advanced R console as well. And you can work then with this environment in this you can work interactively like you would normally, and I will show you in 2 minutes. You can work normally with it as if it were installed on your computer, and you can then use this expression on GitHub Actions, for example, to just deploy exactly the same environment, or you can use this GitHub this default.nix file, this expression. You can use it inside Docker to then just deploy this environment inside of Docker. And then you don't care anymore about the fact that Docker is per se not reproducible, because this reproducibility is handled by Nix. And I also have some code there to show you. So as I said, Rix generates this default.nix file, and then you can build the expression with Nix build. I will show you that. And then you drop into the environment using Nix shell. I will show you this in the demo. Expressions can also be generated even if you don't have Nix installed, but with some caveats. The caveat being, if you need to add a package that is hosted on GitHub, this is not going to work, because Nix needs to be installed for this, because I can show you in the expression, but basically Nix computes a security hash to make sure that the package is the right one. And if you don't have Nix, you cannot compute this hash. But if you don't need packages hosted on GitHub, then it's fine. Then you can generate expression even if Nix is not installed. Okay, I think now. And by the way, you can also add specific versions, even though that's really not recommended, because this will try to install the packages from source. So if it's packages that need to be compiled, it will very likely fail. But if it's not packages, if it's for a package that doesn't need to be compiled, this is going to work. As I said, packages hosted on GitHub works, and there are many vignettes, many vignettes to get started. Actually, maybe I can show you and then drop to the demo. But if you click, you have here all of these vignettes, and if you go through them, I know it's a lot to read, but if you really go through them, you should be in a position where you should be able to use Nix and Rix for your projects. Honestly, only these ones, the A to F, are really important. The rest, as written, is more advanced. But if you go through all that, then you should be able to use it without an issue. But let me show you, or maybe I can take some questions now because I saw that there were in the chat some things. Maybe I can take a couple of questions. And then, or are
Bruno,
there?
do you want me to, maybe I'll read the question out loud so everyone can hear it and then
Yeah.
you respond.
Yeah, let's do it this way. Yeah.
All right, how about this one? This is from Duncan. Um, some packages in R can be installed as a bit of software on your operating system, but other packages are built within R. And then there's others from Bioconductor. Can Nix deal with all these different types of ways of installing software?
So what Nix does is the following. So Nix will not actually download the packages directly from CRAN or Bioconductor. The way Nix works is that we, and when I say we, I mean the R maintainers for Nix. I'm included in that group. We actually, what we do is for every R release, whenever there's a new R release, we generate a huge expression that contains the definitions of all the packages on CRAN and Bioconductor. And then we build all of the packages. We make sure they all work. They don't all work. We have, I think, we are currently at 150 packages that cannot be installed or built with Nix. But like I think the top 3,000 packages all work, and the top 3,000 already cover like 95% of every use case. But it even goes beyond that. So as I said, only like 120 don't work or 150 don't work. And so Nix will download the packages from there, and we work to fix these packages to make them work with Nix. Right, so this means that if there is a package that somehow needs something specific or a bit specific to work, we fix it to make it work. So if it needs something special, like some kind of variable needs to be set or whatever, we do that behind under the hood, so to speak, so that the users don't have to do it themselves.
Bruno, I've got another one from Peter. I think he's asking, does this include R universe packages?
So no, we had some discussion on this. Should we add R universe? And the issue is that what makes CRAN very great is that there are a lot of checks that they already do. So this makes our life much easier, and we know then when we package these R packages for Nix, that the packages are compatible with each other, which is not necessarily the case with R universe or with GitHub packages. So you can still install these packages because most of them, if not all, are hosted on GitHub. So you can just install the GitHub version, but we don't provide like a direct, easy way to install packages from R universe.
Bruno, there's a couple about other languages from Matthew. Can Rix help with multi-language projects, like with both R and Python, for instance?
Yeah, so if you want to add Python packages, that works. And it's basically here you add the Python interpreter, you add Python 3, and then if you want to add pandas, for example, that's a classic, you just add Python 3 pandas and so on. So actually, if you need to find the name of the packages, you can go on search.nixos.org and you see 120,000, and then you type pandas, and this is the name of the package basically. So you put that into system packages, and you will get pandas will be available there. And then when you drop into the Nix shell, you will have pandas available. And so you actually wouldn't even need reticulate, for example. You can just add your packages there, and they'll be available, right? Of course, you can use reticulate then to interact with the Python packages from R, but you don't need to use reticulate to install the packages, is what I mean.
Bruno, here's another one about other languages. It's from Aaron. Is it possible to use Rix in a workflow that uses R and Rust? And apparently some parts of the workflow is proprietary and written in Rust.
So I'm not super familiar with Rust. What I can say is that there are many R packages now written in Rust, and actually we had to fix some of them to make them work. So we had to specify a couple of things. What you can do is you definitely can, this Nix shell, right, that provides R to you. you can add Rust to it as well. I've never done it, but I know that Rust is one of the supported languages. So you could add Rust to this shell. So Rust is also available. Or you could, if you already have a workflow with Rust and an environment that contains Rust, when you drop into the shell, right? And maybe I can show you very quickly just in a terminal, and then I'll go back to the questions. But if I'm in this, this is my terminal, right? If I type something like which git, for example, I have my system installed git. But if I drop into a Nix shell, this git is still available, right? So what I mean by that is that if you have Rust already on your environment, you can drop into a shell, right? Now I'm in the Nix shell. You can drop into a shell, and if you type which Rust C or which cargo or whatever, it will be there, and it should work. I've never done it, but it should probably work. Or you add, you add this to your shell, so it's managed by Nix explicitly. Should work as well.
Bruno, maybe just two more, because I think they're related right now. We have more than that, but this is from Colin. Any plan to create a check to see if your package will work in Nix?
Well, if the package is hosted on, so if the packages is available on Nix, right, through Nix, which is the case, as I said, for 99% of the packages, it's very likely going to work. Of course, there are some that pass through the cracks, but packages that don't work and that we know don't work, we mark them as broken. So if you try to install that package, you'll have an error message telling you this package has been marked as broken. And usually there's a very good reason why it has been marked as broken. So typically a package that builds successfully or that is available through Nix, typically it will work. If it doesn't, do open an issue because then we have to look into it. But it should, I mean, in 99% of the cases, it should work.
All right, one more. This is from Anonymous. Can Rix help obscuring the code for proprietary algorithms or code running in client environments?
So Rix itself won't be helpful with that. But what you can do, I mean, you can with Nix, you can also, just your build procedure can also be just copy and pasting a binary blob, right, somewhere. So you can do that. You can, so for example, you can install Google Chrome with Nix, and there's no source code for Google Chrome, just for Chromium, for example. And so that is just a binary blob that gets installed somewhere. And actually, that's what we do with Positron. So Positron through Nix is not built from source, even though the source code is available, but we just put the binary blob in the right spot, and we add the needed flags that need to be added to make it work. And so you could deploy a proprietary project this way. If you have a binary blob, you can deploy it that way. And if your R package has binary blobs, then I guess it should work with Rix. If you add it as a Git package, by the way, you can also add here a local package. So if you have like a local zip archive or a local tar.gz archive, right, a local tarball, you can also, there's a local packages argument that I'm not showing yet that you can use to install that. And if that local package has binary blobs, I mean, it should work. Yes, it should actually work. But it's not going to help you obscure the code itself. The code needs already to be obscured. All right, so maybe I can switch to the demo and then we can go back to some functions. But so I'm showing this from my Windows laptop, and I'm not a huge Windows enthusiast, but I did this on purpose because I wanted to show you how Nix works on Windows, because I think that's important. Nix actually, to work on Windows, has to work through WSL, which is what I have here. So WSL is actually Linux for Windows, and you see here I have this Linux distribution called OpenSUSE, and it's on this Windows subsystem for Linux. So this is already, unfortunately, a big hurdle for some environments. If you can't have WSL on your machine, then you cannot use Nix on Windows. That's a bit of a problem. But if you are already on Linux or if you are on Mac, then it just works natively. You don't need to do anything. You just install Nix and that's it. On Windows, you first have to have WSL. So that's a bit of an issue. But if you can have WSL, then it's going to work just as it works on Linux. So actually here, as you see, I was on this Nix shell. Now I got out. This is what I'm showing here. This is the WSL terminal. But actually, you could also, go on your computer, if you have, so here it's called Linux, but if you have WSL on your computer, you have just a folder and you can explore it. And this is actually the repository of this talk. So if you clone the repository, you will have exactly the same thing, right? And so I have here this, where is it now? This default.nix, it's over here. So this is the environment where I was able to compile the slides for this talk. Okay, so let me drop into this shell. So as you see, I'm in the right folder. Here is this default.nix that I generated with Rix. And if I type Nix shell, I'm going to drop into this shell. So this means that basically, actually, I should have showed you before. Let me just get out again. If I type which R, so which R would tell you where R is installed. And as you see, I don't have any R installed. So I don't have any R on my system. But now if I drop into my Nix shell, and if then I run which R, then I'm going to have R available, right? Because this Nix shell makes an R available. And as you see, this R is installed in the Nix store, right? And it's this version, the latest version of R, okay? So that's great. So now let's see an actual example of an environment, right, that I want to use for a project. So if I go into scripts, and then if I go into Nix expression and then into Rix intro, I will have several files. So these are the files. Let me show them in the file explorer. So I have this here. So what I have here, I have an R script, two R scripts actually, okay? And if I open the first one, this is basically just this call that I showed you before in the slides. I say, well, I want this date, so a very recent date from last week. I want these packages, and I want RStudio as an IDE, okay? So if I run this, okay, this builds this default.nix file. So it's very scary, but don't look at it, this is generated by Rix for you. But if you wouldn't use Rix, you would need to write it yourself. So as you see here, the R packages are here, the system packages are here. There's this RStudio wrapper. So this is to get RStudio. There's a shell that gets defined, etc., etc. Very complicated stuff. But this 50 lines of code, well, there's some comments here as well. Let's say these 30 lines of code get generated from these 10 lines of R code. And now that I have this, okay, I just execute this script. Now that I have this, I can just type Nix build. So Nix build is going to build the environment for me. In this case, it's going to go very quickly because I already did it, so it's cached. So it's just going to skip basically the build. And then I can run Nix shell, okay? And Nix shell basically will drop me into this shell and will make RStudio and R and dplyr and ggplot available to me. So now if I type RStudio, what's going to happen is that RStudio is going to start. And this is running from WSL on Windows, okay? So this is actually, you see the penguin here at the bottom right. This is because it's actually the Linux version of RStudio, but it's running through WSL almost natively, right? And so as you see, it's running this version of R, right? And if I run over here session info, which we are familiar with, it just tells me, well, the BLAS and LAPACK routines come from the Nix store, right? And if I look here at dplyr, maybe let me zoom in a little bit. Tools. No, I don't use RStudio, so I'm not in. Oh, I zoomed out actually. I don't use RStudio, so I'm a bit lost. But let me zoom in. Yeah, if you look at dplyr is here, and if I load dplyr, look what happens. It's loading it from the Nix store, okay? And it's loading it from the store because I am managing it with Nix. And actually, you should not like run RStudio and try to load packages that are not managed by Nix. It's not going to work, okay? So you really need to run the whole thing managed by RStudio. And now I can just work, right? I can just, I have access to my files, okay? I have access to these packages. I can just work as usual, okay? Let's try something else. Let's go back to the main environment, because the main environment contains Rix. Okay, so if the main environment contains Rix, I can use it to generate new environments, right? So let me drop into the shell and let me go back to scripts, Nix expressions, Rix intro. And you remember I have this script that generates an environment for RStudio, and I have this script that generates an environment for positron. So let's try positron. So if I just drop into R, and if I do source generate env positron, it's going to run this script. So let's run it. It's done. So I can quit now. And let's take a look at default.nix. As you see, Notepad++ is telling me, hey, this changed. Do you want to reload it? Yes, please. So now it's installing positron and not RStudio anymore. Okay. So now if I drop into the shell, oh no, I'm not in the right folder. There we are. Now, if I drop into the shell, this will now load this new environment that contains positron. So if now I type which RStudio, it tells me, no, I haven't found it, no RStudio. However, if I type which positron, it should tell me, here it is. And indeed, there it is. So now if I type positron, it's going to load positron, and I can now use positron instead. And if I add Python to it, I can also choose it here. Actually, this is the system level Python. Not good, don't use that. But I mean, maybe let's try, let's add it. Let me just change the Nix expression. Oh, no, you know what? No, I'm not going to do that. I'm going to use Rix just to show you how it works. So it should be Python 3.12 should provide me with the, if I'm not mistaken, it should provide me with the Python interpreter. And let's try live. When you try things live, it never works. So let's see if I will regret this. Script. So I need to drop into the shell that provides Rix. And actually, if you read the README of Rix, we provide a command that you can run, and it drops you immediately into a temporary shell with Rix available. So you don't even need to have R to just generate your first expressions. You can use Rix immediately from a system that doesn't even have R. You just need to install Nix first, of course. Nix needs to be available, but Rix doesn't need to be available, right? And so that's great. It's explained in the README. So which one did I change? I changed the positron one. Yeah, I changed positron one. So let's see if it's the right name. So this is always going to work because it's not going to get evaluated here. It's going to get evaluated when I try to build it. So if I run now Nix build, if I didn't make a mistake in the syntax, it should try, yeah, here it is. It tried to install Python. So it went very quickly, probably because I already had Python in the cache. So it just linked it. Let's see, which Python? Yeah, here it is. You see, that's the Python from the Nix store. So now let's run positron. And now I should be able to just pick Python from the list of interpreters. Oh, that's weird. There is Python, but it's the system Python. Probably, maybe I need to add some other package. So I need to check that out. But as I told you, when you try things live, it never works. But yeah, but it should work. So I need to check out what's missing. Okay. So I was almost there, but of course something had to not work. But that's weird. And yeah, then Python is added here. So yeah, I definitely need to check that out. I definitely need to see what happened here. So I still have some demos, but Maybe I will let you go through the scripts yourself. Maybe the last thing I want to show you that is specific on Windows is that you can use VS Code from Windows, okay, to interact with Nix shell. So if you have Visual Studio Code, right, on Windows, so this is the Windows version, you can actually use it to interact with Nix shells, okay? So here I'm in this environment, right? And it should work, yeah. So this is actually Visual Studio Code running natively on Windows, but interacting with a Nix shell from WSL, okay? And I also explained that this is explained in the documentation on the Rix's website. So if you want to use this, or if you already use VS Code, you can keep using VS Code and interact with individual Nix shells from within VS Code, from within WSL. It's very seamless, very transparent, and it works quite well, I must say. Unfortunately, that doesn't work with positron. Positron, you really have to start it from the Nix shell, as I showed you. Yes, so I think I will stop here. There are many other things that you can do. I have here a demo that runs targets, a targets pipeline inside of Nix. I have here one that runs a Shiny app inside of a Nix environment. I have another one here that builds a Docker image with Nix. So it's all explained on the website. It's all explained on Rix's documentation as well. So if you have questions, read through the documentation, and of course, don't hesitate to also ask me. And I'm pretty sure that we do have some questions now that I'm going to take.
Bruno, thanks very much. Yeah, if you haven't asked your question yet, use the Q&A icon down at the bottom. Yeah, we have multiple questions coming in. How about from Duncan? A common issue with R code is that as packages get updated, some functions get deprecated, and even some arguments change defaults. What do you recommend we do when the code only runs without error on specific older packages?
So that's the magic of Rix is that maybe if I reshare again, if I show you again the what am I? I don't see the yes, there it is. So this expression here, as you see, is dated. So this is always going to install these packages as of this date. Even if they get updated, you will get the version that came with this state of Nix packages. The environments are stable. So if packages get updated or whatever, if you have a Nix expression like this one, your environment is going to stay exactly the same. It's not going to change. And then if you want to update, for example, if you want to try something new, well, change the date. Add 1 week, for example, or add 1 month or whatever, and rebuild the environment and see if it still works. And so this is also very easily for you to just update the environment. You just add a more recent date and see if things work. And this is actually exactly what I do to develop Rix itself. I have this expression, an expression on Rix's repository, and I keep updating it and see if Rix still works, and if it doesn't, then I need to fix it because it needs to work with the current packages on CRAN.
All right, Bruno, this is in the same kind of vein, but it's maybe like looking back in time from Igor. Would I be able to install some R packages in 10 to 15 years with Rix to reproduce some old academic paper code? I'm asking because some repositories go down, like MRAN from Microsoft. Some don't keep the history for too long. Posit Package Manager goes back maybe 4 to 5 years. So far, I have a feeling that the most sure way to be able to run in 10 plus years is to burn in all the packages in a container, be it Docker or Apptainer.
Yeah, that's a very good question that we thought a lot about. So there's really two things that you should know, or one thing is that Rix, as I explained, or Nix rather, does not install the packages directly from CRAN. So let me maybe show you very quickly where they come from. I will share the screen. Let me just, yeah, here it is. So what happens when cran is very unlikely to go down. If cran goes down, then really it means that R as a language is done, basically. So cran, I think we can be fairly confident that it's going to stay. But Nix itself, the packages come from this GitHub repository, which is one of the biggest, actually, GitHub repositories. And this is, so the package still gets downloaded from CRAN. Don't get me wrong. The package itself, the source code and so on, comes from CRAN. But what happens when you build an expression is that this definition gets used here, and this is the definition that explains how to install these packages from Bioconductor and from CRAN. And it is very unlikely as well that this is going to go down anytime soon, because Nix as well has been around for more than 20 years. And there are actually different implementations of Nix. So there's Nix, there's Lix, and there's Twix. So there's also like competing implementations. So I think that Nix as a standard is very likely going to stick around for a long time. And Nix packages itself, it's just a GitHub repository. So you can literally clone it or fork it, right? And just rehost it and point Nix. Actually, if you look, again, if I show you, actually, we did this. Our fork of Nix packages is our fork where we even apply some specific fixes as well, especially for macOS. So we have better support for macOS on our fork than on the official fork, actually, for Nix. And you can literally just fork it and rehost it. And then what you can do, the ultimate thing you can do is exactly what you did what you say you do at the end, is you generate a Docker image with all the packages, and you can do that with Nix as well. So you can have a Docker file where Nix gets used to build the environment and to make the environment available inside of Docker. And then you run your analysis, your paper, your Shiny app, whatever, inside of Docker, and you store that and you keep it forever. But it's just that the packages were installed with Nix in a reproducible manner. So you can really combine, you can have the best of both worlds, so to speak. So you can do both. Yeah.
All right, Bruno, this is from Tobias. Is there a Nix package for R tools to compile R packages containing C or C++ code, build binary packages, etc.?
So actually, Nix itself contains a so-called standard library. And so basically, if you want to compile packages, you have a Nix function called how is it called again? Build R package, I believe. So it's a Nix function called build R package. So you just add your sources there, and it's just going to compile it, and it's going to use the standard library that covers basically the same as R tools. And if you need then to add, for example, if it's a Rust package, then you can add, you can declare Cargo and Rust C as dependencies as well. Or, if it's a Fortran package or whatever, you add, the Fortran compiler there as well as a dependency. So you can manage that. So Nix has all the tools needed for this kind of thing. Yeah, absolutely.
This one's from Colin. Any recommendations or known pain points when working collaboratively with Rix and Nix?
So there's two things that I think people should be aware of. So I would really highly recommend that if you want to go with Nix, and I know this is psychologically very difficult, but I'm going to say it anyway. If you want to start using Nix, get rid of your system level R and of your system level packages. We tried our best to make Nix shells not interfere with your local R installation, but it can happen. And if it happens, it's just pain. So just take the full Nix pill, right? And just use Nix managed environments. So I say that because if some of your coworkers still have a local R installation, they might complain, oh, but this isn't working or whatever, even though we did our best to make sure there's not going to be any issue, but we cannot cover every corner case. So that's one thing. And the second thing is that there are some differences between Windows and Linux and Mac. So some packages might not work on Mac. So Linux has better support for Nix than Mac. So for example, until very recently, RStudio was not available for Mac. Now it is available, but until very recently, that was not the case. And there are still actually, a user of Rix opened an issue yesterday. Actually, there are still some issues. And I contacted the RStudio maintainer for Nix, and he already has quite a good idea of what needs to be fixed. But there are still some things, right, some things that need to be fixed. And so what can happen is that you can end up with some people working on Linux, some people working on Mac, and maybe the Mac people cannot build your environment. This can happen. If that's the case, then you need to identify which are usually our packages work. That's usually fine. But if you need other system tools that you want to add to your shell, these other system tools may not be available. Chromium, for example, is another example. Chromium is not available on macOS through Nix, and Chromium is needed by some R packages, like I think FlexTable, to generate tables. So on Mac, I guess it's not going to work, for example. So that's also an issue.
All right. Just coming in from Duncan. Can you explain what the minimal extra code is needed for reproducibility other than your data and script.r? Is the Rix function or the Nix expression? Is it the Rix function or the Nix expression it generates?
That's a good question. I would say if you can keep both, right? If you can keep the R script that generates the default not Nix and the default not Nix, I would say keep both, commit both to to version control. But if not, I would say probably the minimum thing you should have is, I would say, still the default .nix, because the default .nix has the advantage that it does not even need R to be available at all. You can literally just copy it to a machine that doesn't have R, just build it. If you have Nix, you still need Nix, of course, but just build it, and then bam, you have R, and you have R packages. So I would say if really you have to choose, probably the default .nix would be the best to keep around, yeah.
All right, we're getting close to the end of the hour. I'm going to do one more question, Bruno.
Yep.
This is from Peter. He calls it the last mile problem. How do we share reproducible projects with folks who are experts in a specific field, but not very computationally savvy? And then he has just a little comment. One hard part with Docker is sharing it with lower tech folks who are comfortable with Word and Excel. But anything more than that is a real problem. Enormous amounts of coaching needed to help them actually use Docker, like collaborator, reviewer, editor.
Yeah.
Those types.
That's a great question. And actually, this morning I had a meeting with some colleagues where we discussed in part about this. And I really think that there is no other way than needing you have to have someone on the team that is very close to the researchers or to the analysts or to the statisticians, but also very close or very IT inclined. So I think there is really no other way than having a close collaborator that knows these things and that helps the colleagues, the analysts, and so on, the more field focused people with this kind of tasks. I think it's very difficult to upskill everyone with Docker or with Nix. Some people are able to learn it. Some people struggle, which is normal because it's not very easy tools, and it's again very far away from what they do on the daily basis. And I honestly think there is really no other solution than hiring maybe a research software engineer, or hiring someone that maybe is a researcher but also very tech inclined. I think I honestly think there's no other solution. So I actually tried with Rix to make it as easy as possible, but there's still corner cases. There's still little things that won't work where you need some expertise. And of course, if you open an issue, I'll try my best to help you, but it's not the same than having someone on the team and just grab that person and ask for help. It's always much easier if you have someone on hand. So yeah, hire research software engineers, I guess, is my final answer.
All right, fantastic. We're going to finish here. This webinar was sponsored by the R Consortium. Thank you very much to Bruno for your time and effort. Thank you to Emily for the information on R Medicine 2025. Please go to the R Consortium website and take a look at the information on the event. This webinar will be available on YouTube. It's probably a day or two, and it will get uploaded. And especially thanks to all of you for participating and your questions.
Thank you very much once again for giving me this very nice opportunity. And yeah, thank you to the attendees and to the discussions. It was really interesting, and gave me some ideas of perhaps some things I need to tweak.
That's great. That's what we were hoping for. Thank you very much.
Thank you. Bye-bye.
Bye-bye.